My dear children, welcome to the mathematics class. Today we are going to discuss integrals. We are going to discuss integrals. In this chapter, we are going to discuss the concepts of exercise 7.2. We are going to discuss the concepts of exercise 7.2. Are you ready to listen the class, my dear children? Right. In the previous exercise, we found the integral of a given function by simplifying the function and by using the standard integral formulae. Okay, my children, but it is not easy to find the integral of a given function always. So, we are using different methods. We use different methods of integration to find the integral of a given function. One of the first methods of integration is integration by substitution. Integration by substitution. In this method, we guess a suitable function. We guess a suitable function which will make the given function into the standard form. We have to guess a suitable substitution which makes the given function a suitable standard integral formula. We have to reduce the given function into the standard integral formula by a suitable substitution. Okay, my dear children, understood? Let us assume that I is equal to integral f of x dx. I is equal to integral f of x dx. So suppose this integral is not in the standard form. It is not in the standard form. In that case, we have to assume some part of the function or the entire function is some variable. We have to substitute. Let x is equal to let us consider x is equal to g of t. Not always x is equal to g of t. We have to choose some part of the function or the entire function. From this function only, we have to select some part of the function or the entire function as some function in t. Then we differentiate on both sides with respect to t. Here variable is x, we are converting into the variable t. So differentiating with respect to t. Then what we get? What is the differential operator? d by dt. Yes, d by dt of x is equal to d by dt of g of t. Okay, my children, understood this step? We are taking the differentiation of the functions on both sides with respect to t. Then we wrote this step. Understood this step, my children? Right. This implies what we get in LHS? dx by dt. d by dt of x is dx by dt is equal to, how do you denote this one? d by dt of g of t. Yes, g dash of t. G dash of t. Understood this step, my children? Right. Now dx is equal to, we send this transform this dt into RHS. Then dx is equal to g dash of t into dt. Just to be transformed dt into RHS. Then what we get? dx is equal to g dash of t dt. Understood this step, my children? Right. Now we substitute here in the given integral. Then I is equal to integral f of x is there, which is taken as x here, g of t, f of g of t. Next, what is there here? Dx. What is the value of dx here? G dash of t dt. So we converted the given function into some standard form. Standard integrals, standard integrals. So by guessing a suitable substitution, we had to reduce, we had to convert, we had to transform the given integrand into some standard integral. Then in this step we get some standard integral. So by using the standard integral formula, we can find the integral of this function. Okay, my children, this change of variable formula is one of the important tools available to us in the name of integration by substitution. This is one of the methods to find the integral of a given function. Okay, my dear children, but generally you have to remember that we have to guess a suitable function which make the given integrand into a standard integral. Okay, my children, that is very, very important part in this integration by substitution. After that, like this, we had to substitute, we had to take. After that, we had to find the derivative. After that, we had to find like this dx. Then we substitute this value, x value, and dx value in the given integrand. Then automatically you get the transformed integrand is a standard integral. Okay, my children, understood this point? If you take some example, you can understand. Okay, my children, right? Usually we make a substitution. For a function whose derivative also occur. The derivative of that function also should be in the integrand. Okay, my dear children, it is very important. This derivative part also should be in the integrand. Please remember this point, my dear children. Right. Now let us discuss some important integrals involving trigonometric functions and their standard integrals. Okay, my dear children, by using the integration by substitution method, we find the standard formula. Okay, my dear children, right. Now see this function integral tan x dx. We don't know integral tan x dx. In the previous exercise we have not learnt this one. So let us find the integral tan x dx. Let I is equal to integral tan x dx. Okay, my children, we have written I is equal to integral tan x dx. We assumed the integral is capital letter I. Okay, my dear children, this is equal to integral tan x can be written as sin x by cos x dx. Isn't it or not, my dear children? Tan x can be written as sin x by cos x. So I wrote this step. Understood this step, my dear children? Right. If you observe, there are two factors. Sin x is one, for numerator is sin x and denominator is cos x. Now we have to choose a suitable part of this integrand. Okay, my dear children, to make this integrand into a standard integral formula. So for that one, I am guessing cos x is equal to t. Put cos x. Put cos x is equal to t. Now differentiating on both sides with respect to t. Differentiating with respect to t. Okay, but do you remember this full form of this sentence? Just I wrote in the short form, differentiating with respect to t. Okay, my children, right? This implies what is the differential operator? D by dt. So d by dt of cos x is equal to d by dt of t. I wrote the differential operator on both sides of this equation. Understood this step, my children? Right. This implies, if you observe LHS, this is not a direct differentiation formula. We have to use chain rule because here variable is x, here variable is t, different variables. So you must use chain rule. So we have to assume that this x as t in your mind. Do you remember that, my dear children? Chain rule. You have to assume x in our mind as t. So d by dt of cos t. What is the d by dt of cos t? Minus sin t. So minus sin x, because we assumed here x as t. So again we write that one into d by dt of x. Chain rule. Understood this part, my children? Right. Is equal to d by dt of t. What will you get here? 1. Understood this step, my children? Right. This implies minus sin x into d by dt of x. What will you get? Dx by dt only. Dx by dt is equal to 1. Understood this step, my children? Right. This implies, if you observe this one, here sin x dx is there. Sin x dx. Sin x dx. So let us find the value of sin x dx from this step. Then what will you get? Sin x dx is equal to, we are sending minus 1 by t that side. So what will you get here? Minus dt. Understood this step, my children? Sin x dx. Here in the numerator sin x dx is there. So sin x dx is equal to minus, we are sending 1 by dt that side. So into dt, 1 into dt we get minus also that side. Understood this step, my children? So we got here sin x dx is equal to minus dt. Understood this step, my children? Now we substitute this value, and this value in this integrand to make this integrand a standard formula. Okay, my dear children? Understood? Right. Let us substitute that values in the given function. Therefore, I is equal to integral sin x dx. We got integral sin x dx is minus dt by cos x is there in the denominator, cos x is there. So cos x is t only, because sin x dx is equal to minus dt. Sin x dx is equal to minus dt. And cos x is t. We are using that results here. Understood, my children? In the given integral, we substituted these two values, then we get this step. Understood this step, my children? Right. This is equal to minus dt by t. Minus 1 is a numerical coefficient. We are writing a numerical coefficient before the integral sum. So minus integral dt by t. Now if we observe this integral, it is a standard form. What is the standard form? Integral dx by x. It is in the form of integral dx by dx. What is the formula? Log mod x. Isn't it or not, my children? Log mod t. Log mod t. Because integral dx by x, integral dx by x is equal to log mod x. Do you remember this formula, my children? Integral dx by x is equal to log mod x. By using this integral formula, we wrote this step. Understood this step, my children? Right. This is equal to minus. Actually, integration formula, integral part is over. But the given function is the variable x. But we got the answer in the variable t. Again, we have to convert into variable x. So log mod cos x. Log mod cos x. Because we assumed here cos x is equal to t. Because cos x is equal to t. So we are again substituting t value cos x. Understood this step, my children? Right. Now this can be written as log mod cos x whole power minus 1. We are using the logarithmic properties. M log a. M log a can be written as log a to the power of m. Log a to the power of m log a can be written as log a to the power of m. Here m means minus 1. So we wrote like this. By using these logarithmic properties, we wrote like this. So log 1 by log cos x whole power minus 1. How can you write? 1 by mod cos x. Isn't it or not, my children? 1 by, because a power minus 1 is equal to 1 by a. Do you remember this loss of exponents, my children? By using this loss of exponents, we wrote like this. So 1 by cos x, how can you write? Yes, secant x. So log mod secant x. So this is the answer. Integral of tan x plus c. At the last step we write constant of integration. Therefore integral tan x dx is equal to log mod secant x plus c. Hereafter we use this result as a formula. Okay, my children, understood? Right. Now come to this second one. Integral cot x dx. Integral cot x dx. Here also we use the method of substitution. Integration by method of substitution. Integration by substitution method. Okay, my children. Right. So first we assume that capital letter I is equal to integral cot x dx. Okay, my children. Right. This is equal to cot x can be written as cos x by sin x. Can we read right or not? Cot x can be written as cos x by sin x dx. Understood this step, my children? Right. In this integrand, see that numerator is cos x and the denominator is sin x. In general, we take the function which is in the denominator for substitution. Okay, my dear children, it is also one of the technique in the method of substitution, integration by the substitution. So let or put the sin x is equal to t. We are assuming that, we are guessing that sin x is equal to t. Okay, my children, understood this one? Right. Now differentiating with respect to t. Differentiating with respect to t. Then what is the differential operator? Yes, d by dt. d by dt of sin x is equal to d by dt of t. We wrote the differential operator on both sides. Understood this step, my children? Right. This implies, now come to LHS, d by dt of sin x. It is not standard differentiation. It is not in the form of standard differentiation, because here variable is x, here variable is t. Different variables. So we must use chain rule. So in the chain rule, what I said, you have to assume that this x as t in your mind. Then d by dt of sin t, yes, cos t. So cos x, we have to write the derivative of this function. So cos x into d by dt of x. Understood this LHS, my dear children? We used here chain rule. Right. Is equal to, come to RHS, d by dt of t. What will you get? 1. Understood this step, my dear children? Because d by dx of sin x is equal to cos x. d by dx of sin x is equal to cos x. d by dt of x is equal to dx by dt, and chain rule. We used these three results to get this step. Understood this step, my dear children? Right. This implies let us write this one. I did not use this step formula here. So just we used only this part, d by dx of, that's all, and chain rule only. We used this one only. Okay, understood this step, my children? Right. This implies cos x into, and d by dt of t is equal to 1. d by dx of x is equal to 1. This result also in RHS. Okay, my children? Understood this step? By using these results, we wrote this step. This implies cos x into dx by dt. d by dt of x value is dx by dt is equal to 1, because d by dt of x is equal to dx by dt. By using this result, we get out this part in this step. Understood this step, my children? Right. This implies here cos x dx is there. If you observe here in the numerator, cos x dx is there. So we find cos x dx value. So this implies cos x dx is equal to, we send this by dt to RHS. Then it becomes into dt. So 1 into dt, we get dt only. Understood this step, my dear children? Cos x dx is equal to dt. Okay, my dear children? Right. Now we substitute this value and this value in the integral, this part. Okay, my dear children? Right. This is equal to therefore I is equal to integral cos x dx. Here cos x dx What is the value of cos x dx? dt by sin x is there in the denominator. Sin x is there. What is the value of sin x here? T. Okay, my children, understood this one? Because cos x dx is equal to dt and sin x is equal to t. By substituting these two values, we got to this step. Understood this step, my children? Right. Now, if you observe this integral, it is in the standard form. What is the standard form? Integral dx by x. Yes, log mod x, log mod t. Because integral dx by x is equal to log mod x. So by using this integral formula, we wrote this step. Understood this step, my children? Right. Again, we have to substitute t value. What is t value here? Cos x. So that is equal to log mod sin x. T means here sin x. Log mod sin x plus c. This is the last step. So we are adding the constant of integration. Therefore, integral cot x dx is equal to log mod sin x. So this result also can be used as a formula. Okay, my children, understood? Right. Come to the third trigonometric function, integral secant x dx. We don't know the formula for this integral secant x dx. So we are finding integral secant x dx by the method of substitution, integration by substitution method. Okay, my children? Right. So let us assume that capital letter I is equal to integral secant x dx. First of all, we have to assume that given integral is equal to capital letter I. Okay, my children? Right. Now, I am multiplying this function. I am multiplying this integrand, multiplying and dividing by secant x plus tan x. Okay, my children? So, integral secant x into secant x plus tan x by secant x plus tan x dx. Here, for our convenience, I multiplied this secant x by secant x plus tan x by secant x plus tan x. Understood this step, my children? Right. Now, in the denominator, what is the secant x plus tan x? I told you previously. In general, we take denominator as a substitution. So put secant x plus tan x is equal to t. We are taking this function for substitution. Okay, my children? Understood? Right. Now differentiating with respect to t. Differentiating with respect to t. We are differentiating the functions on both sides by with respect to t. So d by dt of secant x plus tan x is equal to d by dt of t. I wrote differential operators on both sides. Understood this step, my children? Right. This implies d by dt of secant x. Two terms are there, so we can find the differentiation. We can find the derivative of this function by separately. Plus d by dt of tan x is equal to d by dt of t. What will you get here? 1. Okay, my children, understood this RHS? Right. Now come to LHS. First term, d by dt of secant x. This is not standard differentiation because here variable is x, here variable is t. So we must use chain rule. So we have to assume that this x as t in your mind. So d by dt of secant t. What will you get? Secant t tan t. So secant x. You have to write the derivative of this function. Secant x into tan x into d by dt of x. Because we assume this function as t in our mind. That is why we wrote this one. Chain rule. Understood this first term, my children? Right. Plus here also observe this second term d by dt of tan x. Here also we use chain rule. What will you get? D by, what is the derivative of tan x? Yes, secant square x. So secant square x into d by dt of x is equal to 1. Understood the second term, my children? Right. Because what are the formulas we used here? D by dx of secant x is equal to secant x into tan x. Next, d by dx of tan x. D by dx of and chain rule. Isn't it or not, my children? To get this step, we used these results. Okay, my children, understood? Right. This implies secant x tan x what will you get? D by dt of x dx by dt. Understood this part, my children? Right. Plus secant square x, secant square x, here also we get dx by dt. Dx by dt is equal to 1 because d by dt of x is equal to dx by dt. By using this result, we wrote this step. Understood this step, my children? Right. If you observe these two terms in LHS, what is the common factor here? Secant x into dx by dt is a common factor, isn't it or not, my children? Yes. So I am taking the common factor out. So secant x, I write dx by dt at last, that factor. Secant x, if you take secant x from both terms, what will you get here? Tan x plus, from this term we are taking secant x, what will you get? Secant x into dx by dt. Understood this step, my children? I have taken secant x into tan x as common factor from the two terms. Then we get this factors tan x plus secant x dx. Isn't it or not, my children? Right. From this equation, we have to find, see here, secant x into secant x plus tan x dx. You got numerator. So we have to find that value. So secant x into secant x plus tan x dx is equal to, we are sending this dt to RHS, we are transforming that dt by dt, then it becomes 1 into dt, what will you get? Dt. Understood this step, my children? Now we substitute this value and this value in the integral secant x into secant x plus tan x dx. We got here what that value, secant x into secant x plus tan x dx is dt. So we substitute in the numerator as dt by secant x plus tan x. What is secant x plus tan x? T. We substitute these two values. Understood this part, my children? Right. Now let us substitute that values. Okay, my children? Therefore, integral In the numerator, secant x into secant x plus tan x dx is there. So we substitute dt by t, because in the denominator secant x plus tan x is there, because secant x into secant x plus tan x dx is equal to dt, and secant x plus tan x is equal to t in the denominator. Understood this step, my children? Right. Now if we observe this integral, it is in the standard form. What is the standard form? Integral dx by x. What is the formula? Log mod x. Okay, my children? So that is equal to log mod t, because integral dx by x is equal to log mod x. By using this standard integral formula, we got to this step. Understood this step, my children? Right. Again we substitute t value. What is the t value here? Log mod secant x plus tan x. So this is the final step. So at the last step we add constant of integration. Therefore integral secant x dx is equal to log mod secant x plus tan x plus c. This is also used as a formula. Okay, my children? Remember this formula. Similarly, we prove that integral cosecant x. Integral, I am not proving this formula. You try yourself, my dear children. Otherwise, in the textbook also the proof, the solution to this integral is given. Integral cosecant x. Integral cosecant x dx is equal to log mod cosecant x minus cot x plus c. Remember this also as a formula. Integral cosecant x dx is equal to log mod cosecant x minus cot x plus c. Okay, my children? Remember this is also a formula. These are very useful formulae. Okay, my children? Memorize these formulas well for the exercise. Next upcoming exercises. Okay, my children? Right.